All right, we are going to look at independent events and dependent events, but in form of contingent table. Okay. For example, I'm just going to give an example, then I'll explain from the example. The following table shows the number of accidents caused by drivers who were drunk. And drivers who were not drunk. And drivers who were not drunk. Okay. In breakfast. This is the table. All right, this is the table. And then it's female here. This is a male. This is total. Drunk. Not drunk. And total. Okay. Then we've got 12, 20, 32. 12, 20, 32. We've got 6, 10, 16. Then we've got 18, 30, 48. Okay. Then the question is that determine the probabilities. Determine the probabilities. This is question A. This is number 1. Probability of female. B. Probability of drunk. C. Probability of female and drunk. Female and drunk. Then maybe C, D. The probability of female multiplied by the probability of drunk. Then question 2. Hence, determine whether the relationship of being in the accident, hence, determine the probability. Let's determine the probability of, let's determine the relationship of being in an accident is dependent on gender. Is dependent on gender. Justify your answer. All right, let's start with the first one. A. What is the probability of being female? This is A, 1A. Probability of being female. It is equal to, you're going to where there's female. Total females, there are how many? There are 18. it's 18 over 48, and when you reduce 18 over 48, it gives you what? It gives you 3 over 8, which is 3 over 8. Okay, that's the first one. Then B, probability of being drunk. What is the total of probability of being drunk? You're going to drunk, the total there is 32 over 48. If you reduce that, 32 over 48, you get 2 over 3. Alright, you get 2 over 3, which gives us 2 over 3. Alright, and then you go on to AB, then C, female and drunk. Probability of being female and drunk. The probability of being female and drunk. You go on to female and drunk. It is this one over this one, which is equal to 12 over 48, which gives you 1 over 4. And then part D, probability of female multiplied by probability of drunk. Alright, female, where is female? It's 18 over 48 multiplied by being probability of female and drunk. So the probability of being female, which is 48, and then the probability of being drunk, where is the total drunk? It's 18 over 48, which gives us what? Let me just use a calculator quickly. It's 18 times what is the probability of female? The probability of female is 18 over 48. Then the probability of drunk is 32. Here it's 32 over 48. It's 32 over 48. So it's 18 times 32 divided by 48 squared, which gives us 1 over 4. 1 over 4. Now the next question is that, for this part 2, hence determine the relationship of being in an exam is dependent on gender. Justify your answer. All right, I need to explain on this. It's very easy. Whenever they ask you to determine whether it's dependent or it's independent, there are two things that you must do on your contingents table. First of all, you must say probability of being drunk. Right, you take on this number over this. In other words, you're going to say 12 over, because you're dealing with female and drunkenness. Female and drunkenness. So for female, you're going to say 12 over 48. 12 over 48 is equal to, I'm going to explain again using this simple table. Let's say you have this. Let's say these are your totals. Let's say these are your totals. So you're just going to take this one, A over, let's say M. A over M. Well, these are your totals. Is equal to, let's say, B over M multiplied by C over M. So it's A, which is here. Down this A, you're going to get B. You're going to say equals the figures that, the last figure there, which is B over M. Then the last figure along the row there, where A is, which is C. So it's C over M. That's how you operate. Just like here, you're going to say 12 over 48. 12 over 48 is equal to, the last figure on this column is 32. 32 over 48. This is how you work it out. Multiplied by the last figure there on the row, it's 18. 18 over 48. That's how you check whether it's independent or not. But let me just write it down in form of probability. You're just going to say probability of female and drunk. Probability of female and drunk. It should be equal to, so that it's independent, it must be equal. When it's equal, then it's independent. But when it's not equal, then it's dependent. Probability of female and drunk. You're gonna say probability of being drunk multiplied by probability of being what? Female. What is the probability of being female? Probability of being female, it is 3/8. What is the probability? What is the probability of being drunk? Probability of being drunk, it is 32. Or I have the answers here, which is 2/3. 2/3 from question 1. What is the probability of being female? Which is 3/8. Multiplied by 3/8. Then the probability of being female and drunk. Where is it? Female and drunk, it's 1/4. Then you compare if these two things are equal. Let me just calculate the right hand side. You can see that if you cancel out, then it is equal. It is 1/4, 1/4. If they are equal, let me just write it down. If they are equal, it means independent. If they are equal, it means what? It means independent. If they are not, then they are dependent. In this case, they are equal. So therefore, events of being, because they say that determine whether the relationship of being in an accident is dependent. But therefore, events of being in an accident is dependent on gender, is independent on gender. Why? Because female and drunk, then probability of drunk multiplied by probability of female, these two, they are equal. If they're equal, it means they're independent. But if they are not equal, it means they are dependent. Thank you. All right, today we are going to look at independent events. Whenever you're given independent events, maybe for example, that event P, X, and event PY. If these two events, let me just write like this. For this is probability. Let me just write like this. Event X and event Y. If event X and event Y, if they are independent, let me use another mic marker. If they are independent, therefore, probability of event X intersection probability of event Y, it is given by probability of event X multiplied by probability of event Y. This is for independence. If two events are independent, it means that the intersection of the probability of X intersection Y should give you this. Let me just write this in words. Probability of X or Y, X and Y should be given by probability of X multiplied by probability of Y. That's for independence. So this also applies to this. So this is the most important formula that you must not forget. And this one, this is in words. Probability of X intersection Y, it is the same as probability of X and Y. All right, and then you must not forget this again, whereby events, also if events are independent, two events, let me just say event X and event Y. These two events, there's this formula that you should recall. They always ask for questions based on this formula. probability of x intersection y, it is the same as probability of x plus probability of y plus probability of y minus probability of x union y. Okay. In other words, let me just rewrite in words. Probability of x and y. Probability of x and y. It is the same as probability of x plus probability of y minus probability of x or y. Okay. So these two are the most important that you must not forget. But this is in symbols, this is in words. So if you transpose event P, probability of x or y, what is probability of x union y. If I say union, it is same as or. Union is same as or. It is the same as probability of x plus probability of y minus probability of x intersection y. You must recall this. This is the more. Let me just check them with the let me just check them. This is most important, and this one as well, and this one as well. These you must recall them. Let me just erase everything and rewrite them so that you familiarize yourself with these two formulas for probability. And they always ask these questions for. All right. What I'm saying is these are the most important formulas in probability. For grade 12 CAPS, they will ask you that probability of x intersection y. Let me start with for independent events. Independent events. It is probability of x intersection y. It is given by probability of x multiplied by probability of what? Of y. That's for independent. If events are independent, don't forget this. All right, then don't forget this again. Probability of x intersection y, it is given by probability of x plus probability of y minus probability of x union y. These two, they are very important. You can transpose probability of x, you can make probability of x the subject, probability of y the subject, probability of x union y the subject. You can play around with that and come up with the subject of formula. You know how to make the subject of formula, or probability of x the subject of formula. All right, let's go to a question. Given that event x and event y, given that event x, this is a question, huh? Given that event x and event y are independent, such that probability of y is equal to 0.88, and probability of x intersection y is given by 0.47. Then they say that calculate. We're going to calculate here. A, P, then B. We're going to calculate P, probability of x, and then probability of x x union y, then okay, then ABC. Well, let's start with A, then we'll move on to B, so that I can have space here. Let's start with the probability of x. All right. These, we are given that these two events, they're independent. So in other words, probability of x multiplied by probability of y should give you probability of x intersection y. Where do I get this? I'm going to put a star here. This is where I got this from. So what is the probability of x? Do we have probability of x? No, we are looking for probability of x. So it becomes our formula. Then multiply by probability of y, which is 0,88. 0,88, which is equal to probability of x intersection y is 0,47. 0,47. Probability of y, it is 0,88. Probability of x intersection y, 0,47. Then we must make probability. So therefore, probability of x is equal to 0,47 divided by 0,88. I'm going to use a calculator quickly, which is going to give me 0.47 to 0.88, which is going to give me 47 over 88, which is going to be equal to 47,88. All right, that's part A. Let's move on to part B. Which is question B. What is the probability of x union y? All right, now you need probability of x union y. All right, this is what you asked. This is the question. So how do you do that? We all know that probability of x union y should give you probability of x plus probability of y minus probability of x intersection y. So can you see, I'm going to put two stars here so that you know where I got this formula from. It is from this. All right. Then what is probability of P union Y? We are looking for that, which is equal to, what is probability of X? We calculated, which is 47 over 88 plus probability of Y, which is 0,88 minus probability of X intersection Y, which is 0,47. All right, I'm just going to use a calculator quickly, which is 47 over 88 plus 0.88 minus 0.47, which gives me 20, which gives me 0,94. 0,94, that's the probability. Okay.